So in the last video, I left you with the dimmer knob on the bulb, turned about to the halfway point, and I'm looking at single photon counts coming in. The other thing that's kind of interesting about this apparatus that they have here is they have on the very back of this box, I don't know if I can turn it, oh, I can. They have something called, if you can read that switch, is it going to focus? Come on, give me a little focus here. I don't know if you can read this or not, but right there it says the word cricket on it. And so what cricket is actually a little sound effects generator that'll give a tick every time a photon is detected, almost like a Geiger counter. So if I turn this on, you can actually hear photons coming in. Now, I don't mean that to say that you can actually hear photons, but all it does is takes a pulse coming out of the photon detector, sends it through a circuit, which pulses a little bit of a speaker in there. So I think they're trying to be a little amusing and kind of have a little fun here, because you're used to those clicking noises when we're dealing with radiation and Geiger counters, but now we're doing what the optical photons generated from the bulb. So what I'll do is I'll turn the bulb down a little bit now in intensity. You can tell that the sounds are getting less. Here, I'll turn the bulb all the way down. Okay, so we're back in the dark current, so I'll turn the bulb back up to about half. There's about half. Now I'll turn the bulb up to about 3/4. Getting kind of intense, almost a pure tone. And there's all the way up. So I'll turn it down to about, there's about half right there. So that's kind of an amusing aspect of it, but it sort of allows you to see that indeed you actually have photons sort of going in and hitting the photon detector, and you don't always have to look at, say, the numbers to appreciate what's going on. So what I'll do now, and just in terms of introducing you to the experiment, this isn't quite data yet, but what I'll do is I'll leave both of these on the screen at the same time, and maybe I'll even leave the sound on, and just remember that the light is going through the double slit. The double slit's like right about here, and about here where that micrometer is. The double slit's right about there. So what is hitting the light is interference. The interference is on. And so if I go down to the other end there and turn that far micrometer there, I can scan that analyzer slit across the interference pattern, and we should hear the minimum and the maximum, just to clue you in a little bit to how it works. So what I'll do is I'll get down here now, and I'll just sort of start turning the knob here and see what we hear. See, I've turned the knob here, making the analyzer slit sort of go over this way or that way. I'm not sure which way it's going, but the photon count is definitely decreased, definitely lower. So obviously I've turned this thing so that that little analyzer slit is seeing a minimum in the interference. I'll just keep turning it, same direction. And I'm not getting it to go higher. Maybe I'm sort of on the wrong side of the maximum, but let me keep going. I'm going the other direction now. Okay, the photon counts are getting higher. Still turning it. Now they're getting lower again. Now they're getting very low. So the point is that, sort of make it get high again. There we go. Kind of high again now. So the point is that you're sort of hearing, and I can't see the numbers from where I'm sitting, but you're hearing and hopefully seeing on the screen the up and down of the total photon counts coming in a second. And again, why is that? Because there's an interference pattern coming down here, which has bright spots and dark spots and bright spots and dark spots. As I turn this analyzer slit to slide across it, sometimes I'm letting in the maximum, which will give me a lot of photons. Other times I might be on a minimum, which will give me just a few photons, and so on and so forth. So in the next video, we'll actually take some data, and that'll be our key data. We're going to position this and monitor the number of photons we get, and that will allow us to get data on single photon double slit interference.